So here's a small introduction to space exploration. In the beginning, there was a hard vacuum of nothingness that existed, and the moment that the third dimension, being physical matter, was included into that vacuum, it automatically felt the need to expand in all directions. This is because the physical property of the third dimension is that the physics of the electromagnetic spectrum feels that it must expand by being attracted to gravity, and gravity is the void of a hard vacuum, and that third dimension is attracted towards the hard vacuum of space because the third dimension, being electromagnetic spectrum, being made of the electromagnetic spectrum and having the properties of physics, means that it needs to go in the direction of the heaviest mass. That is also the same cause for magnetic negativity and positivity. So when the original elements of the third dimension were added into the hard vacuum of nothingness, they would have expanded by reacting and being split asunder and having numerous chemical reactions, and expanding outwardly, trying to fill the vacuum of the hard vacuum. So there's the hard vacuum of the fourth dimension, and as the third dimension expands into it, it creates the soft vacuum within of the third dimension. The soft vacuum is what we call space, and when we look up into the stars, we see it, we're looking up at the soft vacuum that we exist within, and we cannot see the hard vacuum of space because it is external from the third dimension. It is external from the electromagnetic frequencies that we live and exist within. The hard vacuum is always pulling out the third vacuum, and it's always expanding the universe. But at the same time, the universe can sometimes trap bubbles of the fourth dimension, bubbles of that very hard vacuum within the soft vacuum. And that small amount of very hard vacuum trapped within the softer vacuum of the third dimension is what forms galaxies, because it works like an anchor, and it pulls in all the elements of the third dimension, the electromagnetic spectrum. They're all attracted towards that harder vacuum, and that's how the galaxies form. There's also some very interesting observations, and that observation is that towards the rim of the universe, being newer and being formed as it's expanding into the hard vacuum of the fourth dimension and creating all those newer elements and newer chemical reactions, the frequencies are closer towards each other, whereas the frequencies closest to the center of the universe that are older are further away from each other. This also means that if we want to look at time as being a physical force, as opposed to a non-physical force, the way that we could see it as a physical force is to say that time moves forward as the universe expands. So as the universe is expanding outwards, time is moving forwards, meaning that if we wanted to go back into time, we would have to shrink the universe back into the position it was, to be back in the time where we existed previously. That means that time travel is not possible unless the universe is shrunk in its entirety, so that we move back into the positions that we wish that we would like to be in. Because the universe is three-dimensional, it's not a two-dimensional like as drawn here. It's three-dimensional. It's a ball. It's a spherical shape. There's a lot of talk of moving and finding us of moving within that, and finding ourselves in different time zones. It's not possible, because to move through the universe means that we have to be physically present whilst the universe is also physically present. And because we know that the universe is physically expanding the entire time, even though we were to move through it as it's expanding, all that would be occurring is that we are aging as we travel through the universe, and the universe would be aging as well. To move closer towards the center of the universe, where technically it is older, and to move towards the rim of the universe, where technically it is fresher and more new, that doesn't mean that we would be moving into the past or moving into the future. It's not possible. We know that space near to the we know that the galaxies near to the center of the universe are further away from each other than the galaxies towards the rim of the universe, and this is because the third dimension is expanding away from the center of the universe. This also creates some interesting effects with times and space and relativity. We can see here that, using this very basic two-dimensional map, that position 1 and position 4, even though they are further away from each other, are at the same length from the center of the universe. That means that they are at the same time as each other, whereas point 3, position 3, being nearer to the universe center, is actually at a different time to them. And even though traveling from point 1 or point 4 to point 3 looks shorter, it's actually, they are still within the same time zone as each other, whereas point 2, being towards the rim of the universe, is newer and fresher than the other 3 positions. As you reach from the center to the rim of the universe, time actually increases in speed. That means that position 3 is technically slower than position 1, and position 1 is technically slower than position 2, because of the way that the universe is stretched. There's a larger space between position 3 and position 1 than there is between position 1 and position 4. And this is to do with the void of the soft vacuum between. Meaning that if you were to navigate through space and time, you could technically go to position 2 very fast, because you'd be going into a faster part of the universe. Although to get there means you would have to travel faster than the universe is expanding, and so that way everything is made relative, and it's very hard to actually discern the differences in the way that the universe is warped, meaning that it usually would take the same amount of time because of the way that the universe is expanding. But what this tells us, though, is how to find and navigate similar life forms. If we are to try and find other life in the universe, we would try and find the life on the same frequency as ourselves, on the same speed of existence as ourselves. So if this here represents the center of the universe, and that represents the rim of the universe, and we live somewhere in the middle, then that means that if we were to find habitable planets and similar life forms to ourselves, we would need to look at the same frequency at the same time as ourselves. So if we imagine that the universe is an inverted bubble, and we happen to be, if the map of the universe is like a bubble, we wouldn't look towards the center of the bubble or out externally from the bubble. We would look at the film that creates the bubble, and we would sail along that same space-time as where our planet existed, so that we would have an increased chance of finding similar life forms. So if this is a map and we exist somewhere on the orange, rather than looking externally at different parts of the universe or looking along different time zones, we have a greater chance of finding similar life forms if we travel along the same time frame that we exist on. In the same way that we wouldn't look for life underwater or in the skies. We know that life exists within a certain temperature, and that's the habitable temperature that mankind exists on Earth. In the same way, we should follow the same time zone that. So here's a basic two-dimensional map of the universe. If point 3 is nearer to the center of the universe than point 2, then we know that point 3 is older than point 2 because point 2 is nearer to the rim of the universe. Whilst point 1 and point 4 being on the same distance from the center of the universe, we know that they exist within the same time, even though that point 4 is further from point 1 than point 1 is from point 2 or point 3. We know that they exist on the same time frame because they are both the same distance from the center of the universe. That means that rather than sending signals to point 2 or point 3, it is more logical to send a signal to point 4, because point 4 would have a higher possibility of having similar life forms to ourselves because it exists in the same time frame, and therefore would have the most possibility of being the same evolved state or the same technological level as ourselves. Also, that the center of the universe has more space in between objects, and the rim of the universe has less space between objects, and so just for simple navigation, it would be easier to travel along the same path of time as ourselves, just in order to make things, in order to continually find similar orbital bodies that we are accustomed to. This can be further explained by looking at a simple map of the universe. Because the universe is third dimensional, we need to think of it as an inverted bubble, that inverted bubble being the time frame of the greatest possibility of finding similar life forms to ourselves, because that layer of the bubble is the same as from the center of the universe to that we exist on, and therefore the center of the universe acts as a navigational point, because from the center of the universe we can measure the same distance to ourselves and then travel to other galaxies and send signals to other galaxies within the same distance from the center of the universe to ourselves. So if this is the center of the universe, we know that this is older, and we know that from further away. This is newer. Therefore, the newer and the older parts of the universe act as navigational points, where we know that the older may have life forms. We know that the newer may have life forms, but the older probably won't have the same life forms as ourselves, and the newer probably won't have the same life forms as ourselves. Therefore, we should travel within the same distance, the same frequency from the center of the universe to ourselves to find similar life forms. If we look at this basic map, if this is representing the center of the universe, rather than going along different time zones looking for life, it's more logical to, if we exist here, it's more logical to send navigators out along the same time frame from the universe center, because this is a band that offers similar, we can expect similar bodies of and orbits to our own solar system, in the same way that we exist in the same temperature, even though different races and different civilizations existed on the earth. We find that always on the same temperature there were civilizations, because it's the most suitable place for habitation, whereas the cold and the heat often didn't provide positions for existing and creating civilization. So if this is a enlarged version, a larger map of the galaxies surrounding us, and this represents the center of the galaxy, the center of the universe, and that represents the rim of the universe, then we know that it makes more sense to send radio signals along the same time frame as ourselves. We know that the same time frame would exist because it's the same distance from the galaxy from the center of the universe as we exist in our galaxy. And it also means that galaxies closer to the center of the universe have a higher possibility of being more technologically advanced than ourselves, or more evolved than ourselves. And planets and galaxies further away from the center than ourselves have, through the fact of being newer and not existing as long as we have, they have a higher possibility of being less evolved and less technologically advanced. Although it also gives the option of having newer, fresher planets to inhabit. This just gives us a very basic outline for how to navigate through the space and the galaxies. If this represents a habitable planet where we exist, we can see that there's a sphere of influence surrounding it for humans, a safe sphere of influence. And if we would like to travel further, then there's a sphere of influence where machines can go that humans cannot. And this is useful for us because we know that if there's a supposedly habitable planet, we can send machines there instead of men to make certain that it is habitable. This can be done remotely using drones. Meaning that we don't even need to leave the planet in order to explore space and explore other more hostile terrains on other planets. And the software and the hardware for this can be crowdsourced and used by corporations and governments as an entertainment to create the software and the hardware, so that when it's ready, then there will be all the it's just a platform to grow that research.